On 5, they tell you that these are the elementary steps, which means that these are the K expressions. And remember, if these elementary steps combine to be this overall reaction, then what we can do is take the Ks and multiply them to get the new overall value. And you can view it as the fractions, but why bother? You can just grab these values. Like if this is 5 and this is 6, you can just multiply them and say that the overall K of the whole thing is 30. On 4, they give you a reaction with moles, and it's in a 1-liter flask, so it's easy to make molarities. There's no product, so it can't run to the left, so there's no point in doing Q. It has to run to the right. And they tell you at equilibrium, after they gave it a shake and a stir and it settled out, they got this much of CCl4, this much molarity. So since they already balanced it for us, and the ratio is 1 to 3 to 1 to 1, if you made 0.3 of this, you also made 0.3 of this, you destroyed, now be careful, 0.9, triple that, 0.9 of this, and you destroyed 0.3 of this, which gives us our final equilibriums. On 7, they give us a reaction, and again, there was nothing given on the right. Excuse me, there was a solid given on the right, but we won't be using it because solids don't have a molarity or a pressure. And what's the question? It's the value of H2O at equilibrium. So I'm going to have to use the K math, but solids don't have a molarity, so forget it. So remember to divide by the 2 liters to get your molarity, and don't bother with a solid, and we didn't have any of this. So it has to run to the right, which means it's got to be creating carbon, don't care, and water some amount. If it creates one of these, it destroys same amount here and same amount here. So it created and don't care and destroyed and destroyed. We can put these values into the K-math, products over reactants to the power of the numbers in front. And because K is 4, this actually does not allow us to cross out X. What I did when I taught this was I said, well, let's just pretend for a minute that if this is a more realistic example, just pretend that K was something like 4 times 10 to the negative 6. In that case, because it's 3 decimals or more smaller than the molarities involved, then it would destroy so little that I can effectively just cross out the X. And that is a big point. It happens all the time on the test where you can cross out plus X or minus X when it's really inconvenient, and it's going to give you a quadratic formula because they use K values that let you do that. Or like number 4, they give you something where you can square root everything and get out of it, just wiggle out of the problem. If it's going to be just 4, though, then you can't cross this out, and the amount that X subtracts will totally matter. And just to be careful, I ran it through the calculator, and it does matter, and you can't skip it, and you get a quadratic formula, which solves us 2 answers. This one's impossible, because with 1.5 and 1.5, you can't create more than 1.5, so that one's dumb. And you get an ending molarity for X, and this time X really is the answer, but don't skip putting the actual answer. Do not just solve for X and put X equals 1. You're going to miss a point on that. You've done all that work and get like half credit. You got an F on that problem because what is the question? It's the ending molarity of H2O, excuse me. And if you put X equals 1, you didn't put a unit, that right there, you're done. You got to put molarity, and it's the molarity of what? You got to state the answer clearly. And I have a saying, numbers without units is not information. You don't get to say, I have 5. People are going to say 5 what? And if you say, I don't know, you're not communicating. You've said gibberish. You have to have 5 somethings. You have to have 1 something. You have to have the units, and you have to know what it's referring to, and you have to state that clearly. On 8, we have a reaction and a Kp. All right, and a temperature, that probably won't matter. They're just saying it to say it honestly. The partial pressure, the torr. So we have values for all these. So this is more like what a short version of the free response question is, where they actually give you A, B, C, D, and they kind of lead you by the hand a little bit and prompt you to solve the intermediate answers instead of just saying, what's the partial pressure of the components, right? like college might, they're going to give you some steps and some hints. So what's the value of the reaction quotient? In other words, what's Q? Take the amounts that they gave you, because they gave you also the values of the products, right? Not just the reactants, but all three. Stuff them into the Q math or the K math, but we suspect very much that this is not at equilibrium, right? So we're going to call it Q math. It's our snapshot K. It's the K math, but it's probably not at equilibrium. It's just at this moment with these values. So we stuff it in, we get 0.093. However, K is 0.060, so Q is too large, which means, again, the top of our fraction is too large, and that's the products, that's the right side, and by proportion, this is too small. So what does that mean? If for Q to reduce in value and reach K, it has to go left. So is it at equilibrium? No. Which way will it go? It has to go left. I wrote in Q's numerator is too big. It has too many products. So if we want to follow the way it's already written out so that we can save K and not have to invert the value, let's write it out this way. But remember, we just said it's going to go left. So that's another reason to make it write out the same way, so that when we say it's going left, it will actually go left, which means we're going to put in our starting amounts and we're going to destroy the right and create the left, because it's going to go left, right? Correct. It's going to go left, right? No, it's going to go left. Correct. So it's easier if you just put in, it's going to create how much? Well, some amount, and I see the proportion is 2 to 1 here. So let's call this 2 of these. It will destroy an equal number of that, and it will destroy 1 of these, or half as much. But we can't use a half, remember. We have to use integers. So this is our ending amounts at equilibrium, and we can put them in. And I also ran this one without crossing out x, and you get the wrong answer. Again, K is too large to just ignore the minus 2x minus x plus 2x. You get the wrong thing. So this is a quadratic formula, so it needs the quadratic formula, and skip that. But anyway, the answer for x is 3. Except that, remember, that is not the final answer, because it was, what are the partial pressures of the components? So put the x value back into these 3 and get your final values.